In production, LLM behavior becomes manageable only when every request is tied to the exact prompt, model, retrieval setup, and routing policy used. That trace turns surprises into diagnoses, rollbacks, cost explanations, and drift signals. So far, we've diagnosed fragile GenAI systems, redesigned serving, and added reliability safeguards. Observability gave us dashboards, alerts, traces, and SLOs. Now we close a critical gap. When behavior changes, we need to know exactly which model, prompt, configuration, or release caused it. In LLM production, the response is not determined by code alone. It comes from a prompt, a model checkpoint, routing logic, retrieval settings, serving configuration, cache behavior, and sometimes a fallback path. Any one of these can change the user experience. So when quality drops, the model got worse is rarely enough. Version tracking gives you a forensic trail for each request. What changed, when it changed, who saw it, and how it affected quality, latency, and cost. Think of each LLM response as the output of a supply chain, not a single model call. The prompt, example, schema, retrieval settings, index, routing policy, model checkpoint, decoding parameters, safety filters, and fallback rules all shape what the user sees. A versioned artifact map records those influences for every production request. Instead of asking only, why did the model say that? You can ask, which exact versions were in force? That turns debugging, audits, regressions, and rollbacks into a reproducible engineering process. Prompt versioning is about reproducibility, not documentation theater. Each meaningful component needs its own stable version: the system prompt, task template, examples, output schema, safety rules, and tool instructions. When these are combined, the resolved prompt should carry a semantic version, changelog, owner, and approval history. The key control is traceability. For every request, store the exact versions that ran, not just the current prompt name. Then, when output quality shifts, you can compare prompt states, isolate the change, and roll back safely. A prompt version identifier has two linked identities. The stable name describes the job, like support response generator, so teams know which capability they are discussing. The immutable version describes the exact runtime content, like prompt, v2.4.1, or a content hash. That second piece is what makes results reproducible. Also version the moving parts around the prompt: examples, schemas, tools, and locale variants. Finally, store operational metadata: owner, approval, environment, timestamp, and change reason. With that manifest, experiments are comparable, rollbacks are safer, and audits are explainable. At runtime, a prompt is rarely just a static template. It may be shaped by user attributes, tenant settings, and experiment flags. That means the system must record the resolved artifact that actually reached the model. Log the prompt name, version, hash, few-shot set, schema version, and experiment bucket. Attach the same metadata to traces, structured logs, and analytics events, so debugging and evaluation reference the same source of truth. Redact sensitive inputs, but keep stable identifiers. Otherwise, you cannot reliably reproduce, compare, or audit model behavior later. Model versioning is more than naming a file. It is the chain of evidence that explains exactly what is running in production. Start with the base model: source, license, and architecture. Then capture the fine-tuned checkpoint, dataset version, hyperparameters, and evaluation results. If the model is compressed, record the quantization format, precision, tokenizer, and compatibility limits. Finally, track deployment time, serving engine, decoding defaults, and hardware profile. This lineage lets teams reproduce behavior, compare releases, investigate regressions, and prove which model answered a real user request. Treat every production model as a lineage, not a standalone file. You start with a base model, then fine-tuning creates a checkpoint with new strengths, weaknesses, and failure modes. Evaluation decides whether that checkpoint is acceptable. Quantization may make serving cheaper and faster, but it can also affect precision, reasoning behavior, or output formatting. Serving choices such as max tokens, batch size, tensor parallelism, and KV cache policy then shape latency and out-of-memory risk. Deployment metadata ties the rollout to metrics, so regressions can be traced to the exact change. Routing policy is the control plane for model choice. It decides which model gets a request, when to fall back, and how much traffic enters an experiment. Because those rules change, treat them as versioned artifacts. A request might be routed by tenant tier, task type, latency budget, priority, or complexity score. The same policy version can also define timeout limits, error rate thresholds, and circuit breaker behavior. For canaries or A/B tests, record the exact split. Most importantly, log both the policy version and the final routing decision for every request. Each routing decision should leave enough evidence to reconstruct why it happened. Log the request inputs the policy used, such as tenant, endpoint, priority, token estimate, complexity, and SLO tier. Then log the result. Selected model, fallback reason, cache decision, retry settings, and policy version. Also capture runtime state at that moment, including circuit status, error rate, queue depth, and GPU saturation. Use the same field names across traces, dashboards, and cost reports, so debugging, reliability analysis, and cost attribution all tell the same story. When you change prompts, models, or routing, don't treat launch as a switch. A canary sends a small slice of real users to the candidate, so you can measure actual behavior while limiting blast radius. Shadow traffic is safer for early validation. Duplicate production requests to the new version, but keep returning the current response to users. In both cases, compare latency, cost, errors, format validity, and quality. Promotion should require explicit gates tied to SLOs and business outcomes, not just a feeling that the test looked okay. Rollback has to be engineered before any rollout. When alerts show a quality drop, cost spike, latency surge, invalid outputs, or SLO burn, the control plane should switch runtime services back to the last known good bundle: prompt, model deployment, routing policy, and retrieval configuration. This works best with feature flags and config-driven releases, not application redeploys. Before cleanup, freeze logs, traces, and version manifests. That preserves evidence for root cause analysis while users are protected by a stable configuration. When a metric drops, version tracking turns a mystery into a testable hypothesis. Imagine JSON validity falls right after a rollout. Instead of blaming the whole system, join each request to the prompt, model, routing, retrieval, and infrastructure versions that handled it. Then segment by tenant, task type, and traffic bucket. If the drop appears only under prompt V18, correlation points to the prompt edit. A rollback or replay test can confirm it. That is the real payoff. Incident response becomes evidence-based debugging, not guesswork. The core message is simple. Treat every LLM behavior driver, prompts, models, retrieval settings, and routing rules as a version production artifact. Carry that version data through requests, traces, logs, dashboards, and cost reports. Then use canaries, shadow traffic, and fast rollback to change safely. Next, we'll monitor quality drift and connect performance metrics to cost.